Okay, so section 4.6 is going to be graphing quadratic inequalities. So we're going to see symbols like less than, greater than, less than or equal to, and greater than or equal to. And so there's a few steps. So number one is we want to graph the quadratic function as if it were an inequality. So we're going to use if it's greater than or equal to, or less than or equal to, it gets a solid line for the parabola. If you don't have the bar under it, it's going to be a dotted or dashed line, okay? So because it's an inequality, then there's more than one answer. There's a bunch of points, so we use that by shading. So some people can tell if something's greater than or less than and just shade above or below, but otherwise we can pick a point and we can test it. If you pick a point, substitute it, and it's true, then you shade that side. If it's not true, then you shade the other region. So the way that we're going to graph these inequalities really depends on if they're factorable, if they're not factorable, the form that's given, and everything else. So let's look at example number one. So what we have is y is greater than x squared minus 4x plus 6. So this symbol means we're going to have a dotted line for our parabola. And then we have a few strategies. So we have three terms. We want to see if it factors, because then we can use our root to kind of graph it. We can use our vertex, things like that. So I think the factors of 6 that we'll add to get 4, well, 2 times 3 gives us 5. 6 times 1 gives us 7 or 5. And so this is not factorable. So what that really means is we're going to use our vertex formula. X equals negative b over 2a. It's also in standard form, so this will always work if you have standard form anyway, okay? If you don't want to factor, you don't ever have to. A is 1, b is negative 4, and c is 6. So on our vertex, we get the opposite of b divided by 2 times a, and then type that into a calculator, we get 2. So our vertex is an ordered pair at 2, and then we want to find the y value. So remember, we plug that into the original. We get 2 squared minus 4 times 2 plus 6, and that gives us our y value. Type that all straight into a calculator, and we get what? 4 minus 8, 2. Okay? So on our graph, I'm going to move this down. We've got the point 2, 2, okay? And so that's going to be our vertex. And this might be enough for you, if it's matching, to be able to match which equation it is. If not, we're going to make a table. So I know that this is 2, 2, and then I get to pick any other x value besides 2. So I'm just going to pick 3. And then we want to plug x equals 3 into the original equation as well to find the y value. Let's use red. So if x equals 3, I get 3 squared minus 4 times 3 plus 6. So we get 3. Okay? So 3 up 3. And then remember, if this is our parabola and that's our vertex, we can use our symmetry. So I've got 3 points. I need to make it a dotted line. And so then I need to shade all the points that are greater. So if you can't tell, we've got this region and then we have this whole region. So if you can't tell which is greater, this is the idea of the point. You pick any point that is not on your graph. So I like to use 0, 0 if it's not running through my parabola. So that means that x is 0 and y is 0. And you're going to plug that into the original to see if it's true. So is 0 greater than 0 squared minus 4 times 0 plus 6. So type the right side into a calculator. We get 6. Is 0 greater than 6? No. So what that means is wherever 0, 0 is, that does not get shaded. So you shade the other part, which is actually going to be between the parabola. Okay? And all of these points that I'm shading, those are your answers. All those ordered pairs make it true. So if I would have picked a point in there and I substituted it, it would have been true. So I need to shade that side. If it's false, you shade the other side. All right, example 2. Well, you have some choices. This does factor. So I can factor if I want, or I can add a +0 and then it's in standard form. And I can do my vertex form again. So here's A, B, and C. So x equals negative b over 2 times a. So the opposite of b, 2 times a, gives us 1. So then to find the y value, we plug 1 in. So 3 times 1 squared minus 6 times 1 plus 0. And we want to type that all straight into a calculator. So we get -3. So on our graph, we've got 1 and then down 3. There we go. And that's our vertex. I know that A is positive, so I know it's going to be opening up. And because we have the bar, it's going to be a solid line for our parabola. So I need to pick another point that's on our curve. So I have 1, -3. So I'm going to pick 0. So if we plug in 0, I get 0. So 0, 0 is on our curve. Okay? Using symmetry, I also know this point, and it's going to be a solid line. Okay? So now we're going to talk about shading. So I like to use 0, 0, but 0, 0 is on our parabola, so I'm not actually allowed to use that. So I have to pick any other number that I definitely know is not. So I'm going to pick 1, 1. So if I try, is 1 less than or equal to 3 times 1 squared minus 6 times 1? I'm going to write it down here. Is 1 less than or equal 3 times 1 squared minus 6 times 1. I'm plugging it into the original. So I'm going to clean up the right. So I get, is 1 less than or equal to -3? Well, no, that's false. So 1, 1 is false. So I don't want to shade where that one is. I want to shade everything that's on the other side, which happens to be more. Okay? All right, my last equation, same idea. I get y is less than x squared. I need to add in 0x and then -5. So 1 is A, 0 is B, and C is -5. So to graph our vertex, we get -b over 2a. So the opposite of b is still 0. 2 times a, and so 0 divided by 2 is still 0. Okay, so if I substitute, I get 0 squared minus 5, which is -5. So that's our y value. So that's our vertex. So 0 and then down 5. Okay, and I need another point. So I'm just going to pick 1. So 1 squared minus 5 is -4. So 1, -4. And then through symmetry, I don't have a bar, so I know it's going to be dotted. Okay. And then I'm going to pick a point. Well, I can tell that 0, 0 is not on my curve. So is 0 less than 0 squared minus 5? Well, is 0 less than -5? No, 0 is bigger. So this is false. So I also want to shade over here. Okay. All right, so go ahead and give that a try on your practice. You have 6 to do, and I give you them to match. There won't always be a ton of work to show, but that's an idea.